Happy Monday, guys. Let the countdown begin. We only have 3 lessons left. So after this one, we only have 2. And then we are down the home stretch. Everybody does have to take the test, so you will have to have all the Hawks done to take that test that we have assigned so far. And I'll try and list those. Or if you need an email to let me know which ones that you don't have done, I can tell you which ones you do need done. Just let me know. So today we're going to talk about determinants and Cramer's rule. Knowing what we know from matrices and the order of them and stuff like that will help us. So the determinant of a 2 by 2, they give you the actual definition right there. However, I'm just going to show you an example and then have you guys do B. So here's what you do. You take 5 and 1 and you multiply them. And then you subtract that from -4 and 7. So you're doing like opposite corners. So I would do 5 minus -28, which would be 5 plus 28. So the determinant for that matrix is 33. Let's practice. I want you guys to do B. And I'll put the answer in the video, but I want you to practice it. Okay, moving on. Now we're going to talk about the minor. So if they give you a minor, what they're telling you to do is they're telling you to cross out a row and a column and then find the determinant. So for this one, I'm crossing out row 1 and column 3. So let's give our matrix right here. Just copying the 1 down from the problem. I cross out row 1 and column 3 to get my new matrix. So -4, 2, 1, and 0. And that's how you find the minor. So now I got to find the determinant of that. So it's what we did above, -4 times 0 minus 2 times 1. When you do that, that's going to be 0 minus 2, so the answer is -2. So I want you guys to try these two. So the second one, they're telling you to cross out row 2, column 2, and make your new matrix. So I'll give you a hint on this one. The new matrix is this. And then find your determinant from there. And that's called the minor. So they ask you to find a minor, that's what you're doing. And then C, I'm going to have you guys do completely by yourself. So I'll put both of those in the video. Next thing is cofactor. So when you're doing cofactor, you're going to use the minor times -1 to that power. So here's how you set this up. So cofactor of 1, 3. They're going to give you a 3 by 3. So I'm going to take -1. I'm going to take the two numbers they want me to cross out, those rows and columns, and add them. And I'm going to multiply it by my determinant of my minor. So if I cross out the first row and the third column, this is what I have left. So this would be -1 to the 4th times the determinant of that. So I'm going to take -4 times 0 minus 2 times 1. This ends up being a +1 times -2. So you would get -2 as your cofactor. Alright, so I'm going to help you guys set up B, and then I'm asking you to do C. So I'm going to take -1 to the 2 plus 2 times the determinant. I'm going to cross out this time row 2 and column 2, and then make my new matrix. So this would be -1 to the 4th times, that's going to be 15 because it's 5 times 3 minus 2. I'll just go ahead and do this one with you guys. So it'd be -1 to the 4th times 13, which would be 1 times 13, which would be 13. As extra practice, I want you guys to do this one right here. I'll throw a question in the video. Alright, so that's pretty much everything so far. Now, it gets a little bit harder. So, to find the determinant of a 3 by 3, it's not as easy as a 2 by 2. Here's what you have to do. You take the first two columns and you copy them and put them on the outside. So 5, -4, 2, 7, 1, and 0. So that's my first step. Your next step, you're going to multiply all the numbers in a diagonal, and it has to be these diagonals first, and then add them. So I would take 5 times 1 times 3, which would be 15. If there's a 0 in there, it's obviously going to be 0, just to show you guys. And then I would add them. So that's going to be 15. And then you're going to subtract the other diagonals all added together. So I'm going to do 2 times 1 times 1, 0 times 0 times 5, 3 times -4 times 7. And then you would add all these and you get -82, so that's 15 plus 82, so the determinant would be 97. I want you guys to try this one, and I'll put it in the video. So you copy the first two columns on the outside and then do your diagonals. Alright? Cramer's rule. So now we're going to solve equations using Cramer's rule. Here are the steps. You want to create a matrix for just the stuff on the left-hand side, just the coefficients. It's called the coefficient matrix, and you want to create a matrix for just the answers. Then you're going to find the determinant of the coefficient matrix, and then you're going to end up using that a couple times. So I'm going to show you what it does. So if they give you this, I'm going to create two matrices, one for the coefficients and one for the answers. So that's your first step. Your next step, so I'm going to say step 2, first step, is to find the determinant of the black matrix, so the coefficient matrix. So I would do 3 times 4 minus -6 times 2. So that's 12 minus a -12, so that turns into 12 plus 12, which would be 24. Now, here's what you have to do to solve for the problem. If I want to solve for the x values, I'm going to take my answer matrix and replace the column that is the x's. So now I'm going to do 10, 4, 2, and 4. So I took my coefficient matrix and I replaced 3 and -6 with 10 and 4 because I'm solving for the x's. Now you find the determinant. You take your determinant and you divide it by the determinant that you found of the original coefficient matrix. And that's going to be the answer for the x one. So in this case, it ends up being 4/3. Now you do the same thing with the y. So now I go back to my coefficient matrix. The 3 and -6 stay the same, but now I'm going to replace 2 and 4 with 10 and 4. So 3 times 4 minus -6 times 10. And you divide it by your original determinant, you get y equals 3. So the answer to this problem would be 4/3, 3. And that's how you use Cramer's rule. It's the same thing with a 3 by 3, right? So same steps. This one's obviously going to take a little bit longer. So find your determinant of that. Don't forget about your answer matrix. So to do this, we copy the first two columns, multiply our diagonals, and add them. So I'm going to do -2 plus -1 plus 2. So that ends up being -1 minus, do the other diagonal, -1 plus -4 plus 1. So that'd be a -4 here. So -1 plus 4 would be 3. So that's a determinant of the original one. Now, to do this, if I want to solve for the x's, I'm going to take my answer matrix and replace the x values in my coefficient matrix. And then repeat the process. Now I got to find the determinant of that. So I'm going to copy down the first two columns. The nice thing is you have zeros in here. You would solve it. So when I do this, I'm going to kind of skip the diagonal part and show you guys what it looks like. So that's going to be -3 plus ends up being a -6. Sorry, it should be minus. -6. So -3 plus 6 would be 3. I divide that by the determinant I got in the beginning. And I replace the x value, so this is my x answer. And then you would do the same thing for y and z. I'm going to let you guys do y and z and figure it out. I will put the answer in here. That's everything today. Your homework is going to be 10.3 hawks. Alright? If you guys have any questions, please send me an email. Let me know. I will be at my computer. Have a good day.